Previous video I give explanation about topics comes under sequences and series. Now in this video I want to solve some problems on sequences and series which are asked question in IIT Jam examinations. This is model questions for prepare IIT Jam mathematics MA maths exam. Now they give that Sn is equal to minus 1 raised to n 2n factorial divided by n raised to 2n to check the convergence of this series. Now we have to check the convergence of series Sn. Now we can take as un is equal to 2n factorial divided by n raised to 2n. Now un plus 1 is, we can take it as 2 into n plus 1 whole factorial divided by n plus 1 raised to 2 into n plus 1. In the place of n we can put n plus 1 in un plus 1. What is un plus 1? Then what is un plus 1 divided by un? Un plus 1 is, first we have to write un plus 1. What is un plus 1? 2n plus 2. 2n plus 2 factorial divided by n plus 1 raised to 2n plus 2. This becomes 2n plus 2. Now un plus 1, this is un plus 1 divided by un. What is un? Divided by un means 2n factorial divided by n raised to 2n. This is un plus 1 divided by un. Now we can write it as 2n plus 1, 2n plus 2 factorial means 2n plus 2 into 2n plus 1 into 2n factorial. Now this we can write it as n plus 1 into n plus 1 into n plus 1 raised to 2n. This is n plus 1 raised to 2n plus 2. If we multiply this we get this, and we can change the sign division by multiplication by making reciprocal this n raised to 2n divided by 2n factorial. Now this can be cancelled out and remaining is here 2n plus 2 divided by n plus 1. We can write it as this type, and into, we can write it as 2n plus 1 divided by n plus 1 into, we can write it as n divided by n plus 1 raised to 2n. This n divided by n plus 1 raised to 2n, this can be cancelled out. Now this is un plus 1 divided by un. Now what is, now we can write this as, here 2 is common here, so we can take 2 into n plus 1 divided by n plus 1. So this can be cancelled out and 2 is remained here. Here we can write it as n plus 2 plus 1 by n divided by 1 plus 1 by n, dividing both side by n. Then 2n divided by n is 2, 1 by n is here, n by n is 1, 1 by n is 1 by n here. Similarly, we can write this as n divided by n is 1 divided by n by n is 1 plus 1 by n is 1 by n raised to 2n. Now as what it becomes as limit n tends to infinity un plus 1 divided by un. As limit n tends to infinity, this is 2 into limit n tends to infinity 2 plus 1 by n, 1 divided by 1 plus n by n. We can write it as and into 1 divided by 1 raised to 2n is 1, 1 plus 1 by n raised to 2n. Now we can write it as limit n tends to infinity un plus 1 divided by un, 2 into limit n tends to, we can write it as limit n tends to infinity into 2 plus 1 by n divided by 1 plus 1 by n into limit into 1 divided by limit n tends to infinity 1 plus 1 by n raised to 2n. By algebra of limits, we can write this as this type, and 2 into as n tends to infinity, n becomes 1 by n 0, 1 by n 0, 1, 2 by 1 is 2. So 2 into 2 into 1 divided by limit n tends to infinity 1 plus 1 by n raised to 2n. Now, what is the value of limit n tends to infinity 1 plus 1 by n raised to 2n? We can take it as limit n tends to infinity 1 plus 1 by n raised to 2n is equal to k. Then what it is ln k? Ln k is equal to limit n tends to infinity ln 1 plus 1 by n. 1 plus 1 by n raised to 2n, we can take it as 2n into ln 1 plus 1 by n. If we apply logarithm, we can take powers as this type. And what is limit? We can write it as 2 into limit n tends to infinity. 2 can take outside. And n we can write it as ln 1 plus 1 by n divided by 1 by n. If we can write this as this type. Now, if we apply L'Hospital rule, what it becomes? 2 into limit n tends to infinity with differentiation of, if any limit x tends to a, f of x divided by g of x. By L'Hospital rule, we can write it as limit x tends to a, f dash of x divided by g dash of x. Similarly, here f of n divided by g of n. Then we can differentiate this and this. Then we can write it as minus, what is differentiation of ln 1 plus ln of 1 plus 1 by n? That is 1 plus 1 by n, reciprocal of this 1. If differentiation of ln x with respect to dx is 1 by x. Similarly, here reciprocal of this, and again if differentiation of ln of 2x, if differentiation of ln of 2x, what we do? 2x 1 by 2x into differentiation of 2x, that is 2. Similarly, here if we apply chain rule, 1 plus 1 by n, if we differentiate it again, we get minus 1 by n square. Now what is denominator? differentiation of 1 by n, that is minus 1 by n square. This is the form of limit extends to a f dash of x divided by g dash of x. Now 2 into this is cancels out, and as n tends to infinity 1 by n becomes 0 and 2 into 1 2, that is we get ln k. We get ln k is equal to 2. Then what is k? Inverse of ln is e, exponential e square. So k is equal to e square. What is k? Limit n tends to infinity 1 plus 1 by n raised to 2n, that is k, that is equal to e square. We know that e is equal to 2.3 something. E square is greater than 4. We can write it as, because 2 square is 4. 2.3 square means it is greater than 4. If so 1 is greater than 4 by e square. So 4 by e square is less than 1. So if we take this and we can apply in the place of limit n tends to infinity 1 plus 1 by n raised to 2n, then in the place of this we can apply e square. So k, value of k we can apply. So we get what? Limit n tends to infinity un plus 1 divided by un is equal to 4 by e square, which is less than 1. 4 by e square is less than 1. 1 is greater than this. So by ratio test we know that what is ratio test? Ratio test says us that if limit an plus 1 divided by an is equal to p, then modulus of p is greater than 1, then series diverges. If modulus of p less than 1, then it converges. So if we apply this here, the value of limit n tends to infinity un plus 1 divided by un is less than 1. So the series (2n) factorial divided by n raised to 2n converges. Then what we can say about series minus 1 raised to n 2n factorial divided by n raised to 2n, it is converges absolutely. We can say it by Leibniz test. What Leibniz test says? Leibniz test says that if minus 1 raised to n un series, if n is equal to 1 to infinity un converges, the series 1 is equal to n to infinity un converges, then n is equal to 1 to infinity minus 1 raised to n into un, the alternative series converges absolutely. So we can write it as this is converges absolutely. So the answer for this question is converges absolutely. Now we can go second question. What is second question? It says that an is equal to root of n and Sn is equal to an plus a2 plus a3 up to an. Here n is greater than or equal to 1. Now we have to find this. Now what is Sn divided by an? Sn means a1. What is a1? in this root of 1 plus what is a2? Root of 2. What is a3? Root of 3. Similarly up to root of n. What is an? Root of n divided by root of n, root of n, root of n up to root of n. Now this will cancel out and we get here 1. So we can write this as, so we can, so Sn by an is, we can say that Sn by an is greater than or equal to, most probably greater, root of 1 by root of n plus root of 1 by root of n up to root of 1 by root of n up to n times. Here n times is there, so we can say that this is greater than or equal to this one. So what this becomes? Sn by an is greater than or equal to root n. This is root of 1 means 1, n times, that is n. So this is equal to root of n. As n tends to infinity, root of n tends to infinity. So by comparing this, Sn by an is greater than this. If this diverges, then this also diverges by comparison test. So we can say that limit n tends to infinity, Sn by an is equal to infinity. Then what it becomes? Limit n tends to infinity, an by Sn, that is equal to 0. Reciprocal of infinity is, we think, 0. So we can write in the place of an by Sn x here. We can put here limit n tends to infinity. In the place of an by xn, we can write it as x minus ln of 1 minus x in the place of an by Sn. They give limit n tends to infinity. What it becomes? N tends to infinity, an by Sn. As n tends to infinity, an by Sn becomes 0. So we can write x becomes 0. If n tends to infinity, x tends to 0. So if we take this, then we get limit x tends to 0, x divided by minus ln 1 minus x. Now by L'Hospital rule, we can write it as limit x tends to 0, differentiation of this 1, differentiation of this term, that is minus 1 divided by 1 minus x into differentiation of this one. Differentiation of 1 minus x is minus 1. So we get limit x tends to 0. This goes up and we get minus 1 into minus 1 plus 1. 1 minus x. We get limit x tends to 0, 1 minus x. So we can write limit n tends to infinity an by Sn by minus ln 1 minus an by Sn as limit x tends to 0, 1 minus x. If we put an by Sn is equal to x, we get this. What is x tends to 0? 1. 1 is the answer for this question. Now we can move third problem. Check the convergence of the series. 1 cube divided by 3, 2 cube divided by 3 square plus 1, 4 cube divided by 3 raised to 4, and so on. Now we can, how we can write this series as? Can we write series in the form of series 3 raised to n cube from n is equal to 1 to infinity? What we get at n is equal to 1? We get 3. At n is equal to 1, 1 cube. At n is equal to 2, 3 square, n cube means, n means here 2 cube. Similarly, at n is equal to 3, what it becomes? 3 raised to, in the place of n, 3, and in the place of n, 3 raised to 3. This is cancel out and we get 1. 3 cube by 3 cube is 1. Plus, similarly, in the place of n, if we apply 4, and in the place of n, if we apply 4, then we get 4 cube by 3 raised to 4, and so on. We get this series by here. So, we can take un is equal to n cube divided by 3 raised to n. Now, we have root test. What it says? If limit n tends to infinity, nth root of an is equal to p. If p is less than 1, then it converges. If p is greater than 1, then it diverges. If p is equal to 1, inconclusive. So, if we apply nth root un of 1 by n, nth root, then we get n 3 by n divided by 3. N by n is 1, so we get 3. If we apply, in root test, we apply limit n tends to infinity. What is limit n tends to infinity? Un raised to 1 by n, that is equal to 1 by 3. This is, we can take outside, limit n tends to infinity, n raised to 3 by n. Now, if we take this as k, then if we apply ln, what we get? 1 by 3 limit n tends to infinity ln. So we can take limit n tends to infinity n raised to 3 by n is equal to k. Then if we apply both sides by ln, then we get limit n tends to infinity 3 by n ln n is equal to ln k. Now we can take 3 outside, limit n tends to infinity ln n divided by n is equal to, what is, if we apply L hospital rule, we get 3 into limit n tends to infinity, differentiation of ln n is 1 by n, differentiation of n is 1, as n tends to infinity this becomes 0, so this whole term becomes 0. This is equal to ln k. Then what is k? Inverse of ln is e raised to 0, that is equal to 1. We get k is equal to 1. So, if k is equal to 1, k means limit n tends to infinity n raised to 3 by n is equal to 1. So, in the place of this, we can put 1. So, limit n tends to un raised to 1 by n, that is equal to 1 by 3 into 1. So, this is less than 1. By root test, if p is less than 1, then it converges. So, we can say that this series is converges. Now, fourth problem is let an be a sequence of positive real numbers. Suppose that L is equal to limit n tends to infinity an plus 1 divided by an. Then which is true? 4 choices are given that. If L is equal to 1, then limit n tends to infinity an is equal to 1. And if L is equal to 1, then limit n tends to infinity an is equal to 0. If L is less than 1, then limit n tends to infinity an is equal to 1. If L is less than 1, then limit n tends to infinity, an is equal to 0. Now, ratio test says that limit n tends to infinity, an plus 1 divided by an is equal to p is if modulus of p less than 1, then it converges. Here they give an is sequence of positive real numbers, so modulus of L is not required. So an plus 1 divided by an is equal to limit n tends to infinity is L. If L is less than 1, then we can say that by ratio test, if L is less than 1, then the series an is converges. Here they give sequence an, and if this satisfies L is less than 1, by ratio test we can say that the series an converges. We have another theorem here that it says that if series an converges, then limit n tends to infinity, an is equal to 0. I told this in previous video. If an series converges, then limit n tends to infinity, an is equal to 0. So here series an converges, then limit n tends to infinity of an is equal to 0. So the choice D is correct answer. If an converges, then limit n tends to infinity, an is equal to 0. So if L is less than 1, then limit n tends to infinity, an is equal to 0. Now, fifth problem is, suppose that S is the sum of a convergent series. N is equal to 1 to infinity, an. This sum is S. Define Tn is equal to an plus 1 plus an plus 2. Then the series n is equal to 1 to infinity Tn. 4 choices are given. We have to check which is correct. Now, n is equal to 1 to infinity an is equal to S. That is equal to an plus a2 plus a3 up to an. This is equal to S. They give that this is convergent series. If this is convergent series, then an plus 1 and an plus 2, they are coincide. They all become limit n tends to infinity, an is 0, limit n tends to infinity, an plus 1 is equal to 0, limit n tends to infinity, an plus 2 is also equal to 0. So, we can write Tn. They defined Tn is equal to an plus a1, an plus 1 plus an plus 2. Summation of n is equal to 1 to infinity Tn, we can write it as summation of n is equal to 1 to infinity an plus summation of 1 to infinity an plus 1 an plus summation of n is equal to 1 to infinity an plus 2. Now, this is S, what they given here. S is the sum of this. So, this is S. Now, what is an plus 1 from n is equal to 1 to infinity? At n is equal to 1, a2. This becomes a2. At n is equal to 2, this becomes a3. At n is equal to 3, this becomes a4 up to an. Sorry, an plus an plus 1. So, an and an plus 1 are as limit n they are, we can say that they are coincide. As limit n tends to infinity, they are coincide. So, I write here only an. Now, here if n is equal to 1, 1 plus 2 is 3, a3 plus a4 plus a5 up to an. Since it is convergent series, we can write it as an plus 1, an plus 2 are coincide. So I write here an. Now we can write here s minus an to this. Why? Because s is the sum a1 plus a2 plus a3 up to an as n tends to infinity. Now s minus an means a2 plus a3 plus up to an. This is a2 plus a3 minus plus a4 up to an. So s minus a1 I write here. Similarly, here a1 and a2 missing. So s minus a2 here I write here. And what it becomes? S plus s minus a1 plus s minus a1 minus a2. Now if we add this, we get 3s minus 2a1 minus 2a2. Since a1 is convergent series, since an is convergent series, this also convergent series, this also convergent series. So Tn is also convergent series. So series converges to 3s minus 2a1 minus 2a2. The choice D is correct. Now next question is the sequence Sn of real numbers given by Sn is equal to sin pi by 2 1 into 2, sin pi by 2 square 2 into 3 and so on. This is sequence of real number. Nth term is this one. Nth term is this one. So we can assume that this is a nth term is one series. This is partial sum of sequence of partial sum of some series. We can assume that this is a sequence such that Sn is a sequence such that what is first term? Sin pi by 2 1 into 2 comma, the next term is sin pi by 2 1 into 2 plus sin pi by 2 square by 2 into 3. So this is second term, partial sums. So up to the last term is Sn, what they given? Sin pi by 2 1 into 2 up to sin pi by 2 raised to n divided by n into n plus 1. Now Sn is equal to sin, we can take this as one series. Nth term is a series. If we consider this is any series, then we can write this one as Sn is equal to 1 to n sin pi by 2n divided by n into n plus 1. So, or infinity. This, if we can take this as series, we can write it this type. Now P series test says that, now consider another sequence, another an is equal to another series 1 by n square. P series test says that if series 1 by n raised to p converges if p is greater than 1, so 1 by n square, this series converges because 2 is greater than 1. This is P series test says. So by this test we can say that an is converges. We know that sin pi by 2n belongs to -1 to 1. Any sine term is range of sine is -1 to 1. So if we take the highest value 1 for this is not 1, but if we take 1, then 1 by 1 plus n into n plus 1 is nth term of this. This is equal to 1 by n square plus 1. This is less than 1 by n square. Now by comparison test, this series converges. The series less than this 1 by n square plus 1, this also converges. This must be converges. Why? Because this converges, so this also converges, which is less than or equal to sin pi by 2n by n into n plus 1. This also converges. So we can say that Sn is equal to n is equal to 1 to infinity sin pi by 2n n plus 1 converges. This series converges. That means the sequence Sn of partial sums, that also converges. We know that we can call convergent series as, so Sn is convergent sequence, which is called as Cauchy sequence. Every convergent sequence is called as Cauchy sequence. So we can call as this sequence Sn of real numbers is Cauchy sequence. Choice D is correct.